Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. We're doing this one question at a time. Here is question 1. A group of high school students wanted to collect information on how many times per week students exercised. If they want the least biased results, they should survey every fifth student at the school who is, and they have all these different choices, entering the gym, in the junior class, entering the library, or entering the building. So the thing here is that we want something that's the least biased. So we're going to want to choose entering the building. So if this is asking at students who exercise, if they're entering the gym, they're probably going to be into exercising, so that would be biased. If they're going to the library, maybe they don't like exercising, maybe they're more of a bookworm, studious type, so they never exercise. And the junior class is limiting it to just one grade level, so entering the building could be anybody from all different students, all different grade levels, and all different interests, which is why it's our choice. Question number 2. Given expression x does not equal -3, which expression is equal to this here? So here we're going to use some synthetic division. So we're just going to take the opposite number here. So we have a 3, so we're going to take -3. And then we're going to take the coefficient of each of this expression up here in the numerator. We're going to bring this down. 2 times -3 is -6. -6 plus 3 is -3. And then just keep this pattern going. So here we're just going to get our answer together. So here we have an x cubed, so we know this is going to be 2x squared minus 3x plus 5 minus 10. And this is our remainder, so we're just going to put this over the original denominator, x plus 3. And I have a whole video on synthetic division if I went over this a little too fast, so please check that out. So our answer here is choice number 2. Question number 3. The table below shows the food preferences of sport fans whose favorite sport is football or baseball. The probability that a fan prefers pizza, given that the fan prefers football, is what? So here, since we have a table, we don't even need to think about a formula. We can just look at this. So we want a fan that prefers football. So if we look over here, the total for football, so this whole section is football. The total here, if we add up, 14 plus 20 plus 6 gives us 40. So we know we're going to be looking for pizza fans out of 40 people. So the number of pizza fans out of 40 people is 20. So this is just going to be 1/2. It's going to reduce to 1/2, which is choice number 1. Question number 4. If f of x is equal to 12x minus 4, then the inverse function of f to the -1x is what? So we're going to be finding the inverse. So first let's write out our equation. So this is really y equals 12x minus 4. So to get the inverse of something, we're going to switch the x and y. So here we have y, so we're going to put x. And then here we have x, so we're going to put y. So we get x equals 12y minus 4. And now what we're going to do is solve for y. So we get x plus 4 over 12 equals y, which is choice number 3. So just to go over what we did here, we switch x and y, and then solve for y. Question number 5. The graph of a quadratic function is shown below. When the graph of x plus y equals 4 is drawn on the same axis, one solution to this system is what? So first let's take this to the side and get it into y equals mx plus b form, so we can graph it. So we're just going to bring this x to the other side. We get minus x plus 4. So this is going to be our b, or y-intercept. So let's go and graph our y-intercept. 1, 2, 3, 4. And then here, -1/1 is our slope. So that means we're going to be going down 1 and to the right 1. So from this point, we're going to go down 1 to the right 1. And we get something like this. So notice these two graphs intersect at 2 points here. At 0, 4 and 3, 1. So our choice here is 3, 1. Yeah, the other choice is 0, 4, but don't be fooled with that 4, 0. So choice 4 is our answer. Question number 6. What is the solution of 2 times 3 raised to the x plus 4 equals 56? So I'm just going to write this on the side here. And let's just try and get this x alone. So the first thing we want to do is divide out this 2. So we get 3 to the x plus 4 equals 28. And now we can use logs. So since we're dealing with exponents, we can use logs and rewrite this equation in log form. So to do that, I'm just going to write on the side like a little tip for myself to rewriting logs. So I like to just think about this because it's a little hard to think about. Log base 10 of 100 equals 2. So it's just a reminder for me of the form of log. So knowing this example, we can rewrite this example. So knowing that, we can write log base 3 of 28 is equal to x plus 4. And now if we want to get x alone, we're just going to subtract that 4 from both sides. So we get log base 3 of 28 minus 4 equals x. And this is our answer, and you could see that this follows choice 1. Question number 7. In a survey of people who recently bought a laptop, 45% they were looking for a large screen, 31% said they were looking for a fast processor, and 58% said they wanted a large screen or a fast processor. So the key thing is or, not and. If a survey respondent is selected at random, what is the probability that the respondent wanted both a large screen and a fast processor? So we actually want to build, this question is kind of complicated and has a lot of information. So what we want to do is build a Venn diagram, our first step, where we have people who wanted a large screen and people who are looking for a fast processor. So the tricky thing here is that they give us values for a large screen, 31%, and a fast processor at 58%. But the thing is, we don't know how many of those people wanted both. So let's, for example, 45% said they wanted a large screen. So that includes x and y. So we have x plus y is equal to 45%. 31, and now over here, new bit of information. 31% said they were looking for a fast processor. So the fast processor, 31%, that is the combined of y plus z. And the last thing it tells us is that 58% said they wanted a large screen or a fast processor. So that's all of these three added together. X plus y plus z is going to equal 58. So the key thing here is or. If it said and, then it would just be y. And they're looking for what is the probability that the respondent wanted both a large screen and a fast processor. So here we're looking for and, we're going to be looking for y. So we have three unknowns, x, y, and z, and we had three simultaneous equations. So there's different ways to do this. I'm going to do it the long way, by hand. There's another way to do this in the calculator. So the first thing I'm going to do, I'm just going to label each equation here, 1, 2, and 3. And we're going to pick, to start, we're going to pick two equations and with the goal of canceling out y. So let's start with these two equations, x plus y equals 45 and y plus z equals 31. So to cancel these out, so remember our goal is to cancel out y. So to cancel out y, we're just going to negate and move this equation around a little bit. So I'm going to move this second equation around so that these two line up with each other. So over here we have, up top we have x plus y equals 45, and over here, so we have the y's lined up, I'm just going to move this z out. Z over plus y equals 31. And now to cancel out the y's, I'm just going to multiply this entire equation by -1. So over here, this equation is staying the same. And down here we get -z minus y equals -31. So when we add these two equations together, we get x minus z, right, because these are different variables. The y's cancel out, and 45 plus -31 gives us 14. So we have x minus z equals 14. So it doesn't look like we've got very far yet, but let's keep going. Let's now pick another pair of equations from our original list of equations over here from our 3 unknown equations with the same goal, the goal of canceling out y. So now I think I'm going to choose, so I'm going to choose 2 different equations. So let's choose 1 and 3. So equation 1 we have x plus y equals 45, and equation 3 we have x plus y plus z equals 58. So the same goal, we want to cancel out y. So to do that, we can multiply this equation, the second equation here, by -1. So when we do that, we're going to keep this top equation the same, and then this bottom equation will be -x minus y minus z equals -58. So notice now we actually cancel out 2 variables. The x's cancel out, the y's cancel out, and we're left with -z is equal to -13. And then we could divide out this -1 and we'll just get z is equal to 13. So now we have one of our variables, z equals 13, but we're still looking for y. So we're gonna take this number 13 and plug it back into one of our original equations to find y. So if we look to find y easily, we can just look at this second equation, bring it down, y plus z equals 31. So y we still don't know, plus now we know z, so we can plug in the value of z, which is 13, equals 31. Subtract 13 from both sides and we get 18. So this was a really long question, surprising for multiple choice, but the answer is choice number 4, 18%. Simultaneous equations when there's 3 unknowns and 3 equations. To review, please check out, I have a video on step-by-step and a bunch of examples on how to do them, so please check it out. Question number 8. In the quadratic formula, b squared minus 4ac is called the discriminant. The function f of x has a discriminant value of 8, and g of x has a discriminant value of -16. So I'm just going to underline these two things. So f of x has a value of 8 for the discriminant, and g of x has a discriminant value of -16. The quadratic graphs of h of x and j of x are shown below. Which quadratic functions have imaginary roots? So since we're dealing with imaginary roots in the discriminant, we're going to be looking for a negative discriminant. So we saw up here that g of x has a discriminant of -16. So we know we're going to be having g of x here, and then they also show these two pictures of these graphs. So imaginary functions, they're imaginary, so they don't actually hit the x-axis, which is exactly what j of x looks like. So we have g of x and j of x is our answer, which is choice 2. Question number 9. The element aramecium has a half-life of 25 minutes. Given an initial amount a sub 0, which expression could be used to determine the amount of americium remaining after t minutes? So when we have a half-life, we know we're going to be dealing with exponential decay. Because half-life means that something is decaying as opposed to growing. So let's just write out the exponential decay formula. And write out what each of these means. So A is the initial value, which they mentioned over here, initial amount a sub 0. So they just kind of represent it by a sub 0. B is the decay, which is 1/2, because we have a half-life. And then T is after so many minutes. So they told us after 25 minutes that this element halves itself. So after 25 minutes. So we're going to represent that by T over 25 minutes. So every 25 minutes, this americium element halves itself. So now we just need to, let's just put it all together. Y equals a sub 0 times 1/2 raised to the t 20 over 25. And let's look for this answer in our answer choices. And we see that it's choice 1. Question number 10. Which function has the greatest y-intercept? And then they have all these different choices. So I'm just going to plug each of these into the calculator and see what the y-intercept is. So let's plug it in. So let's plug in this first one. 4 sine 2x. And with these trig functions, be sure that you're in the right mode. You want to be in radio mode when you're graphing a trig function. So the y-intercept is 0. Yeah, we could see that here. So the y-intercept is just where the graph hits the y-axis. So here it's going to be 0, and we don't know if it's the lowest yet, so let's keep going. So our next one, we have 3x to the 4th plus 2x cubed. So here we can see the y-intercept is 7. Y-intercept is where x is 0. Okay, let's keep going. Let's try the next one. So you see here, y-intercept is 8. And now our last one. So this one is a little tricky to plug in. We have to convert this log base 2. And when we do that, we'll get log base 10 of 3x plus 4 over log base 10 of 2. So let's plug that in. Forgot to put the 6 out here, so let's do that again. So if we plug this in, second table, and you scroll down to where x is 0, you can see that y is 12. So now if we look at all our y-intercepts, 0, 7, 8, and 12, we can see 12 is the greatest, and choice 4 is our answer. Question number 11. According to the USGS, an agency within the Department of Interior of the United States, the frog population in the US is decreasing at the rate of 3.79% per year. A student created a model, P equals 12,150 times 0.962 raised to the t, to estimate the population in a pond after t years. The student then created a model that would predict the population after d decades. This model is best represented by what? So here I'm just going to write on the side 12,150, the equation they give us to represent the frog population. So this is after so many years, but now we're looking for D, decades. So D, right, a decade, 1 decade is equal to 10. So everything on the outside is going to remain the same. So our 12, 150 will remain the same, and you can see that all these answer choices have this remaining the same as well. And then we're just going to raise this to the D to represent decades. So we know this number inside is what's going to change, 0.962. So to do that, we're just going to want to raise 0.962 to the 10 to represent the 10 years. So when we do that, we have 0.962 raised to the 10th, and we get this number 0.6788. So we can round that to 0.679. So this is our new answer to represent decades, which is choice number 2. Question number 12. What is the value of tan of theta when sine of theta equals 2/5 and theta is in quadrant 2? So I'm going to sketch out, there's a couple of things I'm going to want to sketch out. I'm going to want to do a little unit circle. And we know it's in quadrant 2 over here. So that means, so we have sine of theta is positive in quadrant 2, and we're looking for tan of theta, so we know we're going to have a negative answer. So already we can just eliminate choice number 4. So now let's draw a right triangle based on quadrant 2 over here. So just making that bigger and bringing it out. So if we know theta is over here, this is our right triangle, and we write out SOHCAHTOA. So we know that its sine is the opposite over the hypotenuse. So over here, this is the opposite. This is the hypotenuse. This is the adjacent. So we have the opposite is 2 over the hypotenuse, which is 5. And we're trying to find tan of theta, which is the opposite, which is going to be 2 over the adjacent, which we don't know. So to find that, since this is a right triangle, we can actually just use the Pythagorean theorem. A squared plus b squared equals c squared. So we don't know what a squared is. B squared is 2 squared, and then c squared is going to be 5 squared. So we know that a, this unknown sign here, is going to be radical 21. And that tan of theta, remember, is going to be negative because it's in that quadrant 2. So now we have our answer. Tan of theta is equal to 2 over negative radical 21, which is choice number 3. Question number 13. A population is normally distributed with a mean of 23, a standard deviation of 1.2. The percentage of the population that falls below 21 to the nearest hundredth is what? So I'm just going to sketch out a little standard normal curve here where the mean is 23 and then the standard deviation is 1.2, and we're looking for something that's below 21. So if the standard deviation is 1.2, we're going to be going this way to the left, subtracting 1.2 from 23 until we get to something near 21. So when we do that, this is going to be 21.8, and that's almost 21, but it's a little bit higher, so we're just going to go over to the next standard deviation, down one more, which will give us 20.6. So we're going to want to find something that's below 21. So everything from 0 up to 21. Let's just call this 0. So, because we're talking about a population, so we can't have anything in the negatives, right? So our lower bound is going to be 0, upper bound is going to be 21, and then our mean is 23, and standard deviation is 1.2. So luckily we could just easily plug this into the calculator. And this is all the information we're going to need. So we're going to go to second, bars, go down to 2 normal CDF, and then we're just going to plug this all in. The lower is 0, upper is 21. I just happened to do this problem already, so I have this all in here. The mu, which is the mean, is 23, and then the sigma, the standard deviation, is 1.2. And we just press enter, and we get this value, and then we multiply times 100, which will give us the value of 4.78%. Choice number 2. Question number 14. Audra is interested in studying the number of students entering kindergarten in the Alville Central School District over the next several years. Using data dating back to 2015, she determines the number of kindergartners is decreasing at an exponential rate. So we know we're going to be dealing with an exponential function. She creates a formula to model the situation. Here's our exponential function, where x is the number of years since 2015 and y is the number of students entering kindergarten. If there were 105 students entering kindergarten in Alville in 2015, which statement about Audra's formula is true? So this is a lot of information. So I'm just going to sketch out on the side here what this might look like. So she mentioned that the number of kindergartners is decreasing. So we know we're going to have an exponential decay formula. And she gave us that there were 105 students in 2015, which is the initial value, right? Where x is the number of years since 2015, and then in 2015 there were 105 students. So we know that our initial value is 105, and b, they didn't give us any more information, but we do know it's exponential decay. So the thing about that, even though it's decaying, b is always going to be between 0 and 1. So it's going to be positive, but will be a fraction. So even though it's decay, it's still going to be a positive number, even though they didn't tell us what it is. So if we look at these answer choices and glance at them, they're asking about A and B, whether they're positive or negative. And we know that both of these numbers are going to be positive, which is choice number 3. Question 15. The solution set for the equation radical 3 times x plus 6 equals x is what? So here we just need to compute this and find x. So I'm just going to rewrite it down here. The trick to getting rid of a radical is just squaring both sides. And now we're just going to distribute this 3. Move everything to one side. And now we have this quadratic equation. So we get x equals -3 and x equals 6. But before we're quick to circle those answers, let's make sure to check each of these on the side, because maybe we're going to reject one. So I'm just going to plug this back in. 3 times -3 plus 6 equals -3. So here you can see this actually doesn't work out. So we're going to have to reject -3. Now let's check 6, make sure that works. And we get our answer, x equals 6, which is choice number 3. Question 16. The George family would like to borrow $45,000 to purchase a new boat. They qualify for a loan with an annual interest rate of 6.75%. The monthly loan payment can be found using the formula below. What is the monthly payment if they would like to pay off the loan in 5 years? So the monthly payment is what we're trying to find. The amount borrowed is $45,000, our principal. So we could plug that in for P. The interest rate is 6.75%, and we could just convert that to decimal. 0.0675. And I'm just plugging these numbers into the formula. And then our N, number of monthly payments, so they said 5 years. So how many months are there in 5 years? 5 times 12, which is going to be 60. So N is going to be equal to 60. And then this is going to be all over 1 plus the interest rate, 0.0675, all over 12 raised to that 60 months minus 1. So it's just a big calculating problem here. So let's just do one step at a time. Let's first calculate this guy right here. So I'm going to do this one step at a time. So we have this number is 1.40. Now let's find this fraction here. And you always want to write out all the decimals until you don't want to pre-round because this can throw the numbers off when you're looking for the answer. Okay, so now let's do down here. Now let's multiply all these top numbers together. We get $885.76. Choice number 4. Question 17. A retailer advertises that items will be discounted by 10% every Monday until they are sold. And how many weeks will an item costing $50 first be sold for under half price? So there's a couple different ways to think about this. So I thought of this as an exponential decay problem. So the formula for that is a times 1 minus r raised to the x. So our initial value is going to be $50 because it's an item costing $50 first be sold. So it's originally $50, so that's our initial value. And then our discount, it's going to be discounted by 10%. So our rate is going to be 10%. And then we want to know how many weeks it'll take to be under half price. So we don't know how many weeks, or x is going to be equal to weeks. And we want to know how many weeks it'll be less than half price, or less than 25, because we want it under half price. So less than 25. So we can either solve it using logs, or we could even plug it into the calculator. So I'm going to do that. We have 50 times 0.9 to the x, so this can also be written as 50 times 1 minus 0.1 will be 0.9 to the x. Let's go to the table, and if we look for a value that's less than 25, you'll see that the first value that comes up is after 7 weeks, because x represents the number of weeks, and y is going to represent the price that we're looking for. So our answer here is 7 weeks. Choice 1. You could even think about it, doing this one step at a time. So where you have the x values, where it's the weeks, and then y is your prices. And if you just list them out, week 0 it's $50. Week 1 it's going to be 10% off for the first time, and it becomes $45. Week 2, then this $45 is going to be 10% off, and this will be $40.50. And if you do that all the way down, you'll get to 7, which is 23.915. Question 18. The graph of the function f of x is shown below. In which interval is f of x always positive? So we want f of x when it's positive. So f of x is really y, right? The value of y. So we want all the positive values of y, of the y-axis. So everything that is above the x-axis is going to be positive. So our intervals that are positive are from -10 all the way to 0, and 10 to infinity. So if we look at our answer choices, we can see that only choice number 4 is here for positive. So our answer is choice number 4. Question 19. If f of x equals x squared plus 3x plus 2 times x squared minus 4x plus 3, and g of x equals x squared minus 9, then how many real solutions are there to the equation f of x equals g of x? So we just need to find how many times these two graphs intersect with each other, and we can do that by plugging them each into y equals. So let's plug in f of x. And we get this picture here. So you don't have to graph it out on your paper, I'm just doing that so we can have a nice picture of it. And now let's graph g of x, x squared minus 9. And that looks something like this. And you could see that these two graphs intersect at 2 points. So that means there are 2 real solutions. Choice number 2. Question 20. Which expression is a factor of x to the 4th minus x cubed minus 11x squared plus 5x plus 30? And they have all these different choices. So there's different ways to do this. We can graph it out on our calculator and see what factors come up, or since they're in this form, we can do synthetic division. I'm just going to plug it into the calculator. So if we go to our table, we can see we have a 0 at -2 and 3. So there's more zeros if we look here. There should be 3 of them. But we could just see right away this -2 is in our answer choice. If there's a -2, we know that the factor x plus 2 is going to be included in here. Because if we set this equal to 0, we get x equals -2. So we know that choice 1 is our answer. Another way you could do it is doing synthetic division. If you just take the synthetic division of this factor right here, doing all the coefficients, bringing this down, 1 times -2 is -2, -2 plus -1 is -3. And you could see that this is a factor because it has a remainder of 0. So we know that x plus 2 is a factor. Question 21. The expression x squared plus 6 over x squared plus 4 is equivalent to what? So here we're going to do some division. Long division of polynomials. So we could see that x squared plus 4 goes into x squared plus 6 one time. And then we're left with a remainder of 2. So we get 1 plus 2 all over that original number we were dividing by, giving us our answer of 1 plus 2 over x squared plus 4, which is choice number 4. Question 22. Stone manufacturing has developed a cost model, C of x, and then we have this representing cost, where x is the number of sprockets sold in thousands. The sale price can be modeled by S of x over here, and the company's revenue by R of x equals x times S of x. The company profits R of x minus C of x could be modeled by what? So if we want to get the company profits R of x minus C of x, we're going to be doing x times S of x minus c of x. So this will take some writing out. This is like a big computing problem. So let's write x and s of x first. So s of x is 95.4 minus 6x, and then it's going to be minus all of c of x. And here is c of x up here. So now let's just distribute everything. Let's distribute this x. And then now the tricky part here, let's distribute this -1 and negate this entire thing here, c of x. And now we just need to combine like terms. So we have one x cubed term minus 0.18 x cubed. Now let's look for the squared terms. We have two of those, minus 6x squared minus 0.02 x squared will just give us minus 6.02 x squared. And next we have just the plain old single variable, 95.4x minus 4x, which will just give us plus 91.4x. And then we have one whole number minus 180. And we get this as our answer. And when we look in our answer choices, we see that this lines up perfectly with choice number 3. Question 23. Which function is even? So an even function is a function that is symmetric over the y-axis. So just in a little example, something like a parabola that's symmetrical and looks like that. So let's go through each of these answer choices and see which of these is symmetric. So if we look at choice 1, x cubed plus 2, you can graph this on your calculator and you'll see it looks something like this. So you can see this is not symmetric about the y-axis. So that's not our answer. Choice 2, f of x equals x squared plus 1. Graph this on the calculator and it's going to give us that parabola we want that's symmetric about the y-axis. So choice 2 is our answer. Question 24. The graph of a cubic polynomial function p of x is shown below. If p of x is written as a product of linear factors, which factor would appear twice? So if you look over here, notice this is tangent to the x-axis. So that means that there's going to be an even power attached to this factor. So if you look at what the factor is, it's minus 2. So that means it's going to be x plus 2 squared. And just to find the other factor, since this is a cubic function, we know that this is going to be x minus 3, the other factor. So our answer here is x plus 2, choice 2. So that's the end of part 1. Look out for part 2 coming out soon. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!